Welcome to sureshbhattclasses. We are solving questions on quantitative aptitude topic numbers. Quantitative aptitude topics are useful for all competitive exams like bank PO, railways, SSC, CGL and many more. These topics are useful for all job interviews as well as extremely useful for all entrance exams like GRE, SAT, ACT, CAT, GMAT, etc. In this video, we are going to learn how to make divisibility rule. Point 1. Divisibility rule of 7. The digit at ones place of the given number should be multiplied by 2 and number obtained should be subtracted from the given number, leaving the digit at ones place. If number so obtained is divisible by 7, then the number is divisible by 7. This process can be repeated till we get easy number. How this rule was made? We have to find multiple of 7 which ends with 1 or 9. That number is 21 which ends with 1. Now 21 minus 1 is 20. Therefore x equal to minus 2. Here x equal to minus 2 is a tens place number called negative oscillator. Or we can take 49 which ends with 9. Now 49 plus 1 equal to 50. Therefore x equal to 5. Here x equal to 5 is tens place number called positive oscillator. As multiplying by 2 is easier than multiplying by 5, hence we opted to multiply by 2. Now I explain it, the theory. If any given number is there, then we multiply 2 to the ones place of that number and then we subtract the number so obtained by multiplying by 2 from the given number, leaving the ones place or units place. And whatever the remainder we get, if that number is divisible by 7, then the number is divisible by 7. We can also multiply the last digit by 5 and then we add that number obtained by multiplying the 5 to ones place number, and after that what number we receive, if that is divisible by 7, then the number is divisible by 7. Why we subtract 2? As 21 minus 1 is 20 and the tens place number is 2. As we had subtracted 1 from 21, that's why we are subtracting the number after multiplying by 2. And why we add 5? As we get 49 plus 1, here plus is 1 and we get 50 and tens place digit is 5. The tens place digit 5 is called positive oscillator because we are going to add the multiplication of 5 to the ones place, and minus 2 is called negative oscillator as we subtracted 1 from 21 to get 20. I will explain you this by example. We will find the divisibility of 7 for number 924 and 45,724. 924. The ones place is 4. Now we have to multiply 2 to this 4. So 4 times 2 is 8. So after leaving this 4, the number remains is 92. So what we do, leaving this 4, we subtract 8 from 92 and we get 84. As we know that 84 is divisible by 7 because 12 times 7 is 84. So the number 924 is divisible by 7. Again, the multiplication by 5. 924, one's place we multiply by 5, that comes out to be 20. We add 20 to 92 after leaving 4. On adding we get 112. Now 112 is divisible by 7 as 16 times 7 is 112. So 924 is divisible by 7. But it was easier to multiply 2 rather than multiplying 5 to 4 and do the operation. That's why we opted to multiply by 2 and subtract it from the remaining portion of the number instead of multiplying by 5 to 4 and adding it, because multiplying by 2 is easier rather than multiplying it by 5, and subtracting small number 8 is easier than adding 20. That's why we have made the divisibility rule by multiplying by 2 and not by 5. You will learn more from the next example. The next number is 45,724. We multiply 2 to the last digit 4. 4 times 2 is 8. Now we subtract it and we get 4564. Again this number is big number. So what we do, we multiply again the last digit 4 by 2 and we get again 8, and after leaving the 4 last digit we again subtract 8 from 456, we get 448. Again this number is big number. So what we do, we repeat the process again. We multiply 2 to last digit 8 and we get 8 times 2 is 16. Now leaving the last digit 8, we subtract 16 from remaining number which is 44 and we get 44 minus 16 is 28. Now we know 28 is divisible by 7, hence the number 45,724 is divisible by 7. We can do this process by addition of the number after getting the number on multiplication of 5. 45724. The last digit is 4. If you multiply it by 5 we get 20. Now we have to add it. Here previously we were subtracting the number as the oscillator was negative. Here the oscillator 5 is positive, so we add. On adding 20 we get 4592. Again this number is big number, so we multiply again the last digit by 5 and that number is 10. On multiplying 2 by 5 we get 10. We add 10 to the remaining number 459 and we get 469. Again this number is big number. So what we do, again we multiply 5 to the last digit, which is 9 times 5 is 45 and we add 45. 46 plus 45 is 91. We know that 91 is divisible by 7 for 13 times. But on observing both the process, multiplication by 5 or multiplication by 2, it is easier to multiply by 2 and subtract the number so obtained from the remaining part of the given number, rather than by multiplying 5 to the last digit of the given number, then to multiply it by 2. And then the number sometimes on multiplication by 5 is bigger number, like here on multiplying by 5 to 9 we get 45, and to add 45 to 46 is difficult part, rather than a small number 8 or 16 then to add 45. Therefore, we took the option of multiplying by 2 and subtracting it from the remaining part of the number. I hope you have understood the entire process of making a divisibility rule of 7. Now we will make the divisibility rule of next prime number 13. Point 2. Divisibility rule of 13. The digit at ones place of given number is multiplied by 4 and number obtained is added to given number, leaving digit at ones place. If the number so obtained is divisible by 13, then the number is divisible by 13. This process may be repeated till we get easy number. How this rule was made? We have to find a number multiple of 13 which ends with 9 or 1. That number is 39, because in 39 the number is ending with 9. Now 39 plus 1 equal to 40. Therefore x equal to 4. Here x equal to 4 is a tens place number of 40, is called positive osculator. As this is positive, that's why we add after multiplying by 4. You will learn this rule by some example. The first example we are taking is to find whether number 962 is divisible by 13 or not. What we do? The last digit is 2. We multiply 4 to this last digit 2, and 4 times 2 is 8. And after leaving this 2, we add 8 to 96, and on adding we get 104, and the number 104 is divisible by 13, as 13 times 8 is 104. So the whole number 962 is divisible by 13. If you still get the difficulty in dividing 104, then we can repeat this process again. The last digit of 104 is 4. So we multiply 4 to 4 and we get 16. And that 16 we add. After leaving 4 we get the number 10, that is 10. 10 plus 16 is 26. And 13 times 2 is 26. Therefore the number 962 is divisible by 13. Now we go to the next example. The second example, we have to find the divisibility of the number 262184 by 13. The last digit of this number is 4. So we multiply 4 to this number 4, that gives us 16. And after leaving this last digit 4, we add 16 to the remaining part of the number, and 6 plus 8 is 14. We write 4 and carry 1. 1 plus 1 is 2 plus 1 is 3. Now the number which we get is 26234. The number is still big and we cannot divide this number easily by 13. So we again repeat the process. The last digit again here is 4. So 4 times 4 is 16. Now we add 16 to the remaining part of the number after leaving the last digit. 3 plus 6 is 9. 2 plus 1 is 3. And we write 6 and 2 as it is. The number so obtained is 2639. Now 26 is divisible by 13. Then again on the remainder will be 39. That is also divisible by 13. But still this number is large. And if you want to make it more easy number, then we repeat the process again. The last digit is 9 and 9 times 4 is 36. So we add 36 after leaving the last digit 9 to the remaining part of the number, that is 263. 263 plus 36. 3 plus 6 is 9. 6 plus 3 is 9. And we carry 2 as it is. 299 is still large. So we repeat the process again. The last digit here is also 9. 9 times 4 is 36. So we add 36 to the remaining number after leaving 9 is 29. And 29 plus 36 is 65. And we know that 13 times 5 is 65. Therefore, the entire number 262184 is divisible by 13. If some people feel that 65 is still big number, then we can repeat the process again. 5 times 4 is 20. So we add 20 after leaving last digit 5, and 6 plus 20 is 26. And we know that 13 times 2 is 26. This way you can find the divisibility of 13 and you can learn how this rule was made. Now we will learn to make the divisibility rule of next prime number 17. Point 3. Divisibility rule of 17. The digit at ones place of given number is multiplied by 5 and number obtained is subtracted from given number, leaving the digit at ones place. If the number so obtained is divisible by 17, then the number is divisible by 17. This process may be repeated till we get easy number. How this rule was made? We have to find a number multiple of 17 which ends with 9 or 1. That number is 51, which ends with 1, as 17 times 3 is 51 and 51 ends with 1. Now 51 minus 1 equal to 50. Here we are subtracting 1 and we are getting 50. Therefore x equal to minus 5. As we are subtracting it, so we are writing it as minus 5. Here x equal to minus 5 is a tens place digit called negative oscillator. 5 is tens place digit and we are writing minus because we are subtracting 1 from 51. That is why we are subtracting the multiple of ones place digit after multiplying it by 5 from the remaining part of the number. You will learn this rule from examples. In example 1, the number is 952 we have to find whether this number is divisible by 17 or not. The last digit of this number is 2. So we multiply 5 to the last digit 2, and 5 times 2 is 10. After leaving this last digit 2, we subtract the 10 from remaining part of the number, and that part is 95. 95 minus 10 is 85, and we know that 17 times 5 is 85. Hence the number 952 is divisible by 17 because 85 is divisible by 17. As the oscillator was 5 and it was minus, that's why we subtracted. After multiplying 2 by 5 we get 10, and we subtracted 10 from 95 as the oscillator was minus 5. We go to the next example. The given number is 60826, and we have to find whether this number is divisible by 17 or not. The last digit of this number is 6. So we have to multiply 5 to this number, and 6 times 5 is 30. So after leaving this last digit 6, we subtract 30 from the remaining part of the number. 2 minus 0 is 2. 8 minus 3 is 5. We carry 0 and 6 as it is. So the number we obtain is 6052. This number is still large, so we repeat this process. The last digit of this number is 2. We multiply 5 to this 2, and 5 times 2 is 10. After leaving the last digit 2, we write 10 and subtract it from the remaining part of the number, and that part is 605. And on subtracting we get 595. This is still a large number, so we repeat this process, and the last digit of this number is 5, and 5 times 5 is 25. So we subtract 25 from the remaining part of the number after leaving 5 is 59. 9 minus 5 is 4, and 5 minus 2 is 3. So the number is 34, and we know that 17 times 2 is 34. That is 34 is divisible by 17. Hence the entire number 60826 is divisible by 17. Hope you have understood the divisibility rule of 17 and how this rule was formed. Now we go to the divisibility rule of next prime number 19. Divisibility rule of 19. The digit at ones place of given number is multiplied by 2, and number obtained is added to given number, leaving digit at ones place. If the number so obtained is divisible by 19, then the number is divisible by 19. This process may be repeated till we get easy number. How this rule was made? We have to find a number multiple of 19 which ends with 9 or 1. That number is 19 itself, which ends with 9. Now 19 plus 1 is 20. Therefore x equal to 2. Here x equal to 2 is tens place digit called positive oscillator. You will learn this divisibility rule and how this rule was made by some examples. The first example is we have to find whether 912 is divisible by 19 or not. The digit at ones place of 912 is 2. We multiply 2 to this 2 and we get 2 times 2 is 4. And after leaving the first digit or units place, we add this 4 to the remaining part of the given number, and 91 plus 4 is 95. And we know that 95 is divisible by 19, as 19 times 5 is 95. Therefore, the given number 912 is divisible by 19. If some people still find that the 95 is tough number, so we again repeat this process. We multiply 2 to the ones place digit, which is 5, and 5 times 2 is 10. So after leaving ones place digit 5, we add 10 to the remaining part of the number, which is 9, and 10 plus 9 is 19. Now 19 is divisible by 19, so the given number 912 is divisible by 19. The next example is, we have to find whether the number 21432 is divisible by 19 or not. The digit at ones place is 2, and we have to multiply 2 to the digit at ones place, and 2 times 2 is 4, and leaving the digit at ones place, we have to add this 4 to the remaining part of the number, and on adding 4 to remaining part, 3 plus 4 is 7, and we carry 4 as it is, 1 as it is, and 2 as it is. So the number becomes 2147. Now this is a large number, so we cannot say that whether this number is divisible by 19 or not. So we repeat this process again. The ones place digit is 7 in this number. So 7 times 2 is 14. Leaving the last digit 7, we add 14 to the remaining part of the number, and 214 plus 14 is 228. Again 228 is a large number. We repeat this process, and the ones place digit of this number is 8. So 8 times 2 is 16, and leaving ones place digit 8, we add 16 to the remaining part of the number, which is 22, and 22 plus 16 is 38, and we know that 19 times 2 is 38. So the given number 21432 is divisible by 19. Hope you have understood the divisibility rule of 19 and also how this rule was made. Now we will go to the divisibility rule of next prime number, which is 23. Point 5, divisibility rule of 23. The digit at ones place of given number is multiplied by 7, and number obtained is added to given number, leaving digits at ones place. If the number so obtained is divisible by 23, then the given number is divisible by 23. This process may be repeated till we get easy number. How this rule was made? We have to find a number multiple of 23 which ends with 9 or 1. That number is 69, which ends with 9, as 23 times 3 is 69. So 69 is that number which ends with 9. Now 69 plus 1 is 70. Therefore x equal to 7. Here x equal to 7 is a tens place digit of 70 called positive oscillator, and that's why we are multiplying the last digit by 7, and as we are having 69 plus 1, here the plus sign is there, therefore we add the number so obtained after multiplying the ones place digit by 7 to the remaining part of the given number. You will learn this by example. The number in example 1 is 943 and we have to find the divisibility of this number by 23. The digit at ones place is 3 and 7 times 3 is 21. So after leaving 3, we add 21 to the remaining part of the given number, and the remaining part of given number is 94. 94 plus 21. 4 plus 1 is 5. 9 plus 2 is 11. And we have to find whether 115 is divisible by 23. If it is divisible by 23, then the given number 943 is divisible by 23. And we know that 23 times 5 is 115. Therefore, the given number is divisible by 23. But for some people, 115 may be large number, so we can repeat this process again. And the ones place digit of 115 is 5. 7 times 5 is 35, and leaving 5, we add 35 to the remaining part of the given number, and that number is 11. 11 plus 35 is 46, and 23 times 2 is 46. Thus 46 is divisible by 23. Hence the given number 943 is divisible by 23. We go to the next example. The given number is 61456 and we have to find whether this number is divisible by 23 or not by using the divisibility rule of 23. The ones place digit is 6 and 7 times 6 is 42. So after leaving this ones place digit 6, we add 42 the remaining part of the given number. 5 plus 2 is 7, 4 plus 4 is 8, and 6 1 we carry as it is. Now the number becomes 6187. Again the number is large and we cannot find the divisibility of this number by 23. So we repeat this process again. The ones place digit of this number is 7 and 7 times 7 is 49. Now after leaving the 7, we add 49 to the remaining part of the given number, which is 618, and 8 plus 9 is 17. We carry 1. 1 plus 1 is 2 plus 4 is 6, and we carry 6 again. So the number becomes 667. Again this number is large, so we repeat this process again, and ones place of this number is again 7. So 7 times 7 is 49, and we add 49 to the remaining part of the number, which is 66. 6 plus 9 is 15. We carry 1. 6 plus 4 is 10 plus 1 is 11, and we know that 115 is divisible by 23, as 5 times 23 is 115. Therefore, the given number 61456 is also divisible by 23. But if you have still the difficulty, then repeat the same process as we have done in the first example. Here you see that 115, we repeated this process again, and finally we got 46, and 46 was divisible by 23. Therefore the given number was divisible by 23. Similarly, we will get 46 at the end, and 46 is divisible by 23. Therefore the given number 61456 is divisible by 23. We go to the divisibility rule of next prime number. which is 29. Point 6, divisibility rule of 29. The digit at ones place of given number is multiplied by 3 and number obtained is added to given number, leaving digit at ones place. If the number so obtained is divisible by 29, then the given number is divisible by 29. This process may be repeated till we get easy number. How this rule was made? We have to find a number multiple of 29 which ends with 9 or 1. That number is 29 itself, which ends with 9. Now 29 plus 1 is 30. Therefore x equal to 3. Here x equal to 3 is a tens place digit of 30 called positive osculator. As we add 29 plus 1 to make it 30 and 3 is the tens place digit. Therefore we multiply this 3 to the ones place digit of given number and then we add to the remaining part of the given number, and that is why it's called positive osculator. You will understand by some example. So we go to the example first. In example 1, the given number is 812 and we have to find whether it is divisible by 29 or not. Ones place digit of 812 is 2. Now what we do? We multiply 3 to this number 2. 3 times 2 is 6 and we leave 2 and the remaining part of the number is 81 of 812. 81 is the remaining part. We add this 6 to 81 and this becomes 87. Now we know that 3 times 29 is 87. Therefore 812 is divisible by 29. If you have difficulty in dividing 87 by 29, we can repeat this process again. We multiply 3 to ones place digit of 87, which is 7. 7 times 3 is 21. And after leaving 7, we add 21 to remaining part of the number 87, which is 8. And 21 plus 8 is 29. And 29 is divisible by 29. Therefore, the given number 812 is divisible by 29. The second example is number 52374, whether this number is divisible by 29 or not. The ones place digit is 4. We multiply 3 to this ones place digit. 4 times 3 is 12. And leaving this 4, we add 12. 4 times 3 is 12 to the remaining part of the number after leaving 4. And that part is 5237. And we have to add 12 to this. 7 plus 2 is 9. 3 plus 1 is 4. And we carry 52. So this number becomes 5249. This number is still large and we cannot determine whether it is divisible by 29 or not. So we repeat this process again. The ones place digit of this number is 9 and 9 times 3 is 27. And after leaving 9, we add 27 to the remaining part of the number. So 4 plus 7 is 11. We carry 1. 2 plus 1 is 3. Plus 2 is 5. And we carry 5. Now the number is 551. 551 is still large number. So we repeat this process again. The ones place digit is 1. And 3 times 1 is 3. And leaving 1, we add 3 to 55. the remaining part of the number, and 55 plus 3 is 58, and 29 times 2 is 58. As 58 is divisible by 29, therefore the given number 52374 is also divisible by 29. Now you can understand the divisibility rule of 29 and how this rule is formed. The next prime number is 31, and we will form the divisibility rule for 31. Point 7. Divisibility rule of 31. The digit at ones place of given number is multiplied by 3 and number obtained is subtracted from given number, leaving digit at ones place. After subtracting, the number so obtained is divisible by 31, then the given number is divisible by 31. This process may be repeated till we get easy number. How this rule was made? We have to find a number multiple of 31 which ends with 9 or 1. That number is 31 itself, which ends with 1. Now 31 minus 1 equal to 30. Therefore x equal to 3. Here x equal to 3 is tens place digit of 30, called negative oscillator. Why it is called negative oscillator? Because we are subtracting 1 from 31. You will understand this by some example. The example is 868, and we have to find whether this number is divisible by 31 or not. The ones place digit is 8, and 8 times 3 is 24. So after leaving 8, the remaining number is 86. We subtract 24 from 86. 6 minus 4 is 2, and 8 minus 2 is 6, and we get 62. And we know that 31 times 2 is 62. Therefore, the given number 868 is divisible by 31. We go to the next example, and the given number is 23436, and we have to find whether this number is divisible by 31 or not. The ones place digit is 6, and 6 times 3 is 18. After leaving 6, we write 18 and subtract it from the remaining part of the number after leaving 6, which is 2343. 13 minus 8 is 5, and 3 minus 1 is 2, and we carry 2, 3 from the above. The number now is 2325. This is still large, so we have to repeat this process again. The ones place digit of this number is 5, so we multiply 3 to 5, and 5 times 3 is 15, and after leaving 5, we subtract 15 from the remaining part of the number, and that part is 232. We have to subtract 15 from 232. We carry 1 from 3 to make it 12. 12 minus 5 is 7, and 2 minus 1 is 1, and we carry 2 from above, so it is 217. The number is still large, and we cannot divide directly by 31, so we repeat this process again. So 7 times 3 is 21, and after leaving 7, we subtract 21 from the remaining part of the number, which is 21, and 21 minus 21 is 0, and 0 is divisible by any number, so it is divisible by 31. Therefore, the given number 23436 is divisible by 31. Hope you have understood the method of finding the divisibility rule and the divisibility rule of 31. Now we will make the divisibility rule of 37, 41, 43 and 47. Divisibility rule of 37. We have to find a number multiple of 37 which ends with 1 or 9. So 37 multiplied by 3 is 111 which ends with 1. Now 111 minus 1 is 110. Now we leave this 0 and the remaining part is 11. Value of x here is 11 and x is called negative oscillator. Because why it is negative? Because we are subtracting 1 from 111. So it is called negative oscillator. For finding the divisibility of 37, what we have to do? We have to multiply the last digit or ones place digit by 11 and then we have to subtract from the remaining part of the number after leaving digit at ones place. That is the purpose of calling it as negative oscillator. And the method you already know from the previous examples of divisibility of all other prime numbers explained earlier in this video. Divisibility rule of 41. Again, we have to find a number which is ending with 1 and multiple of 41, and that number is 41 itself. So 41 minus 1 is 40 and we leave 0 of 40 and we get x equal to 4. As we are subtracting 1 from 41, so again the 4 is negative oscillator. Divisibility rule of 43, and we have to find a multiple of 43 which is ending with 9 or 1, and that number is 43 multiplied by 3 is 129. Now 129 plus 1 is 130, and after leaving this 0 we get x equal to 13, and 13 is positive oscillator because we are adding plus 1 to 129 to make it 130. Divisibility rule of 47. 47 multiplied by 3 is 141. We had to find a multiple of 47 which ends with 1 or 9, and 47 multiplied by 3 is 141. That number is ending with 1. So 141 minus 1 equal to 140, and after leaving this 0 we get 14. So the value of oscillator x equal to 14, and as we are subtracting 1 from 141, so it is negative oscillator. If a oscillator is negative, then we have to subtract, and if the oscillator is positive, then we have to add. The role of oscillator, that we have to multiply the ones place digit of any number by this oscillator, and whatever number we get after multiplying this number to the ones place number of the given number, then we add if it is positive oscillator, and we subtract if it is a negative oscillator from the given number leaving the ones place digit. And if that number after subtracting or adding we get is divisible by these number 37, 41, 43 or 47, then that number is divisible by these numbers. I hope you have understood the method of forming divisibility rule of prime numbers. Here completes this video. Please watch all my videos on quantitative aptitude topics. These videos will be helpful for you to face all types of competitive exams. Please like, share and subscribe to this channel, and don't forget to press the bell icon to get the latest notification. Thanks for watching.